Cool. All right. Thanks for the intro. Sorry for the technical difficulties. I'm Steve Fox, founder of Architecture as Code, focused on building tools to help teams deliver applications with AI that are both fast to iterate on and reliable to operate. So I'm excited to be here. Glad to have the opportunity to speak with you. I've been through several paradigm shifts in my career, but I got to say this AI revolution is like nothing else I've seen, and it just keeps accelerating. And just watching these presentations today just highlights that. It's like everywhere you turn, there's something new to learn. So I got the presentation up. Just a heads up, I don't have the extra screen, so I don't see the chat. So we'll hold those off to the end. Hopefully I have enough time to go through them. If not, you can reach out to me with any questions afterwards. So I saw this cartoon the other day, it made me laugh. Hopefully you got a kick out of it like I did. Also made me think what's going to be the next meaningless metric. So I've gone through pain on every one of those. All right, so this conference is about applied AI, and my talk is about our particular journey with spec-driven development. So I thought I would organize this in a kind of a story format. So our story begins around June of 2025, where I'll say the first half of that year was kind of like dominated by the whole vibe coding craze after Karpathy's tweet, and then Claude Code coming out, and everybody's trying to figure out what is this thing and what can we do with it. Then the first kind of event on spec-driven development history was Brian Madison released BMAD in around April. And although it wasn't really spec-driven development, it was more of a methodology. It was kind of the first underpinnings of spec-driven development. And it was one of the first alternatives, really, to vibe coding. And then Kiro came out in July, and that was the first one to actually kind of focus on specs as a core artifact. And then in September, GitHub published SpecKit, and the whole SDD movement really started to pick up momentum at that point. But one of the observations I had putting this talk together was that was only a year ago. I mean, by normal tech adoption standards, this is just amazing how fast things are going. So our particular story went through multiple spec-driven development projects. We tried pretty much every framework that was out there at the time. They started to proliferate, so you couldn't try them all, but we went through 6 or 7 at least. And our experience was about the same with each one, slight variations. Like the first iteration was like, wow, okay, this is the path forward. Second iteration was a little painful, a little confusing. What are we supposed to do here? By the 5th iteration, you're always sitting there scratching your head, like, is this actually helping us or is it hurting us? Is it introducing artificial artifacts and processes? Like, what's the flow here? So I don't want to go into too much detail, and the different frameworks approach this differently, but just as kind of a high level generalization, most of these frameworks follow a very similar top-down functional decomposition approach. They give different names to the different levels, but in almost every case, you start off with some high level thing like a PRD, go through a series of interview questions with the AI that breaks it down into subcomponents that you then go review. And you just keep doing this process till you get to a low enough level of abstraction that you can hand it off to the AI. That's the general flow. So for me and a few other senior engineers, by senior meaning the true gray hair, that actually lived through this kind of ancient period of software development, it really started to feel an awful lot like waterfall of the 90s. I mean, it was just document after document. You got to put eyes on everyone. And by the second or third or fourth iteration, your eyes are bleeding. You're just like, AI is supposed to make things faster, not slower. So it started to feel very painful and like, is this really the path for AI to future development? And then even after you go through all that, the thing that kept sticking in the back of my head is like, the code is still the source of truth. It's like, we can't even count on the spec. We still got to go to the code. So something just felt off about this, and I'm not alone in this. And I know there's different arguments all over the place about why it's different, but in general, that was our perception, at least middle of last year. So here we are in October of 2025, and we kind of have these two very different competing perspectives. We have the whole vibe coding is like, oh, the models will just keep getting better. They'll solve every problem. And then the whole spec-driven development, which is, oh no, you got to document everything up front. And it just, after trying both, it started to feel like there's no middle ground. They're like, there has to be some better way. And I was really struggling with this, with the different projects I was working on at the time, trying to figure out what is a middle ground here that makes sense. So back to our timeline. Here we are in October of 2025, confused, what's the way we're going to go here? And this is where we have the plot twist in our story. And that twist is an article came out called Levels of Spec-Driven. This article was published by Brigitte Bachler on martinfowler.com. It was a really good discussion about what was going on with spec-driven development approaches at that time. Didn't get a whole lot of attention at the time, but later in the spring of 2026, it got picked up and expanded on by multiple Medium authors. Mr. Wasowski is probably one of the bigger ones, but if you Google it, you're going to see it all over the place now. But I think Brigitte was the first to coin these three terms, and I remember reading it way back in October, and it had a really big impact on me. So a virtual thank you to you, Brigitte. It really helped change my perspective on this and probably helped put me down a different path than I was going before. And what I found really interesting about her coverage of it at the time, even though Spec-as-Source was kind of the only one that really named it, is what she was calling out was a dimension of what is your source of truth. You know, if it's spec first, which most of the frameworks are and were, it's code. Like, and that was one of the problems I was having. It was like, if code is your source of truth, like, what are we, how much value are we really getting from this? And then the spec anchored was really this kind of blended. It's not really the spec, it's not really the code. You got to keep syncing them back together. And it's only if you get to spec as source that you really have the spec is source. And like you can actually go delete the source code. So that clarified things a lot for me, but probably even bigger was she just asked some really fundamental questions. And the one that hit me hard is, what is a spec? She's like, there's no agreement on what a spec is. Different people call it different things. So it really got me thinking in a number of different ways and at the right time, at least for me. So coming out of this, I had several realizations. One is there were just too many degrees of freedom for AI. And that was part of the reason why we had all these documents. We had to constrain the AI or it just would go off on its own, pick whatever it decided to do if it wasn't forbidden to do it. And I even went through, and I encourage you to do this, go through and give your favorite AI tool a PRD and just say, hey, how many order of magnitudes of different solutions could you estimate to come up with from just this PRD if I didn't give you any other constraints? And I was surprised a little bit, not quite too much. Answer came back from Sonnet 5.0 was actually 10 to the third, 10 to the fourth. So we're talking thousands of solutions. That feels like too many degrees of freedom to me. So, but the other thing coming out of that I kind of alluded to is spec could be an artifact other than a markdown file. And I thought, this is interesting, might be able to do something with that. So for chapter 2, decided to do an experiment. That experiment is, can we build a spec with enough constraints built into it to limit the AI's degree of freedom enough that we can actually build it reliably? Can we achieve spec as source of truth? So to do this, started to add some constraints. First constraint, we're going to constrain the solution space. We're only going to focus on back-end APIs. That was a majority of the work we were doing at the time. Seemed like a reasonable solution space narrowing. The second one was a pretty big one. We're going to require clean architecture. Some of you may know what that is. I can go to it in slightly more detail, but it's a rule set to further limit the solution space. And then the third one was a little unorthodox at the time, at least. We're gonna deviate from markdown files and define the clean architecture artifacts in a schema verifiable YAML. This limits the expression space. So our rationale here was if we did this, we could probably exclude some 99% of the possible solutions that could satisfy a PRD and hopefully reduce the documentation burden that was required to otherwise reduce the solution space. So that was our goal. At a high level, we were wanting to change this game to be this game. So starting from a PRD, generate and review an architecture.yaml, which these two documents together become your source of truth. And then we generate code from that. That's the goal. But there was a few challenges here. And I know one of the things people are immediately thinking is, well, you're just shoving all these documents into a YAML file. No, what we're actually doing is applying clean architecture rules here. So what goes into this YAML are things like domain, entities, applications, ports, adapters. YAML looks like this, customer definition. We can show it like an ERD format. This is the format of the architecture.yaml. So another nice benefit of this abstraction is this was the layer I was already thinking in when architecting systems for years before AI even came along. So one of my goals was, can I have a conversation with the AI at this level? Like, can I talk about these entities instead of line number 200 at file XYZ? So this part I wasn't too worried about. This mapping is relatively straightforward. You have a decent schema definition for the architecture.yaml. You give that to a decent AI model with a decent prompt, and you still get a human review cycle on it. This one I thought we could tackle pretty easily. The one I was worried about was this one. How do we get from that architecture.yaml to actual executable code? And could we do it with the current model set? Wasn't sure, but I thought if we could, this would be interesting to pull off. So a little sidetracked here, but or part of the reason I was concerned was when I was struggling with these first few SDD frameworks, I really unpacked them and looked under the covers to see like what they were doing. And I noticed a pattern. They're all doing this for a reason, which is fundamentally you have to get down to this level for one main reason, which is you have to fit the task into a limited AI context window. If you don't, you give too big a task, it will struggle, hallucinate, and even outright deceive you at times. So like this is something you're gonna have to do if this is gonna be practical. So the question becomes, how could we do that? So the first natural approach here was like, we already have this natural decomposition by clean architecture layers. We can use those layers and automatically get like a decomposition by layer 4, which is good, it's natural, but that's not enough. It's still way too granular. So the next thing we decided to do was let's go by entity. So from each domain entity, let's split it up for each layer. So like, for example, customer, product, order. And this is good because it goes across all the layers, but it's still not enough. So we went to a third layer, which is actually a task type. So within each one, we have one that's writing the test, one that's implementing the tests, and another that's verifying. But it's not just verifying the test pass, it actually analyzes the code and says, did you follow all the clean architecture rules? Are you following the reference patterns? If not, it'll kick it back, give it reasons why it failed, and give it a chance to go try again. But the key thing here was all of these rules being built up, all of these prompts were domain agnostic. So you could be building a CRM system or a travel site, it really doesn't care. So, end of chapter 2 results. We ended up with about 60 specialized prompts. An example would be like domain entity test writer, domain entity implementation, etc. And went through months of tuning, scoping, organizing prompts. It was brutal at times, but it finally worked. We actually got to the point we could delete source and rebuild an executable REST API strictly from the architecture.yaml. We were excited. We had a spec artifact that was source's truth. We were here and we partied for about a day. And then we realized the rebuild was really expensive. It took 1 to 3 hours of just cranking away, 5 to 8 million tokens, sometimes more. So we started to cheat. Started to go right into the code again, make modifications, and then go update the spec to match, do nightly builds to try to catch any drift. So as excited as we weren't there. We actually fell right back into spec as anchored. So that was one of the realizations of that, is like spec as source of truth is only going to work and be practical. It's quicker and easier than bypassing it. Otherwise, you're really at spec and anchor, no matter what you want to claim. So back to the timeline. Here we are at about January of 2026. So we thought, well, I mean, we did it. It's not very efficient. It's not practical. But what do engineers do? We go in and start trying to optimize. Can we make this more efficient? So our primary goal was to optimize the rebuild time. Yeah, just like my cartoon jokes, the tokens didn't like, there's a dollar cost associated with that, but I could tolerate that if we actually have the quick iteration time, because the human productivity just jumps up so much. So we started analyzing, where's the usage, where's the waste, what can we do to make this more efficient? Well, one of the first things that jumped out is, why don't we start looking at each individual prompt? And we started to notice there was a lot of things going on in the prompt that really was deterministic and could be factored out into MCP tools, which run faster and use less tokens. So we thought, all right, this is a good step. So we went down that way, with fervor. And I noticed this, in fact, earlier in Eshburn's talk about the Fluent Graph stuff earlier, how deterministic tools are being used to help constrain AI. I think that's a pattern we're going to see more and more. And I think it's one we should look for. So we had good results. It took months, but we got to a 50% improvement. So we took it down from 1 to 3 hours to 30 to 90 minutes. Tokens from 5 to 8 million down to 2 to 4 million. And, it was good. I mean, that's pretty good, 50%, but it's still too painful. I mean, we're not going to wait an hour and a half for a simple change. So what we really only changed was, instead of daily rebuilds, we're doing 2 or 3 a day, but we're still in there modifying code. So something interesting happened here when we hit this point, is the more we looked for these deterministic tools, the more we started to realize, hey, there's a whole lot of this stuff, more than we expected. We could probably get 75% of this mapping from architecture.yaml into a source for a REST API. We could do it deterministically. So we started thinking, what if we change our approach? What if we go from this, AI using tools, generating code, to this? What if we have a generator generate as much as it can deterministically, and then spin off AI surgically to go off to the pieces? So we went from this type of model, this type of architecture, to this. An orchestrator calling MCP, doing a massive heavy lifting on most of what it can, and then making decisions based on what came back from that to say, okay, we have these 5 files you need to go do something with, and spinning those off. This turned out to be better than we expected. We went from 30 to 90 minutes down to 3 or 5 minutes, because we're asking the AI to do less work. The tokens dropped dramatically. We're down to 500,000 or less. But most importantly, we're back at source of truth for the spec again, because it's the easiest path. You actually naturally go to the spec and change it than looking at the code, because it's actually quicker to get there. And the cognitive load was lower. So we were pretty excited about this. But there's even a bigger hit that I want you to kind of absorb here. The real win, in my opinion, was the ability for the human to focus at a higher level of abstraction. Because as soon as you do this, and you can do it effectively in like less than 10 minutes. This green box, black box, green box, whatever you want to call it, it really becomes an API compiler from Spec. You don't care whether it's AI in there or not. It's just a machine to you. And as soon as that happens, and it's easy and quick to use, you quit looking at the code and you start focusing on the architecture. This shift is big. So if you get nothing else, I want you to just kind of absorb that in, because that's something, it was part of the goal and I didn't quite realize how important that was until we started to see it affect like how it projects and how you can iterate. And I think it's not only possible, it is the future for a lot of AI-driven development domains. So that's the core of my experiences with my journey through spec-driven development. I'm at the 22-minute mark here. I really wanted to try to do a live demo for this talk, but I realized pulling the slides together that was not going to happen. Just wouldn't be enough time. So instead, I published our demo to YouTube channel. It's here. And then I grabbed a few screenshots I can go through briefly in the time remaining, but you can go watch that at your leisure if you're so interested. But the core of the demo is basically to start from nothing but a PRD and go through to a working MVP. But the takeaway isn't really that you can do that. We all know we can generate code with AI. The real takeaway is, what does it take to do iterations after you get to that first MVP? What is involved? Are you generating documents? Are you reviewing things for hours? Or are you making quick changes and seeing quick things? So I'll go through just a couple of quick slides, and then again, you can check the demo later, and then I'll jump into answering any questions that are probably packing up on the chat. But a point is, I threw a timer on there so you can actually see wall clock, but it's really kind of boring watching clock work. So I'll fast forward through pieces of it. But essentially, by 4 minutes in, we actually have an architecture based upon just analyzing the PRD. And when we run that through the generator, we actually have an API up and running at the 10-minute mark. We generate data so we can actually look at it, and we have that running around 14 minutes. But here's where it gets interesting. So we have a working MVP, let's say at 15 minutes, but we want to make changes to it. This is where most of the existing frameworks start to struggle, in my opinion. So we just want to add an attribute. We add it to the model, run it through the generator, and it's live by the 18-minute mark. You're almost like, well, that's even faster than I expected. It wasn't 15 minutes, it was 3 minutes. Why? Because we're tracking deltas. We're not generating the whole thing, we're only generating the parts that changed. And this is part of the focus about just keep the iteration speed as fast as you can. Another change, we want to add another method to one of the entities. This one is a little more involved because it does involve kicking off AI, but even that took about 4 minutes, and then we have that live. And then we did kick off, you can go through the demo, we did kick off actually building a React UI to it. It's not really part of our focus, but one of the points of it I find interesting is when you put out a good solid API first, it makes generating the UI that much easier because it constrains itself too. It's like, you can only use this API. So that gives it structure, format, and data transfer objects that most of the time you can generate a reasonable UI in like 1 or 2 shots. All right, so I'm going to back out here. I'm not going to go through this in too much detail, but those are the 4 chapters we went through. Main thing was about reducing degrees of freedom so that the AI becomes more reliable and focusing on iteration speed. So I'm just going to sum up here with just a few takeaways. First is spec can be source of truth, and it delivers some large benefits if you can. Iteration time is one. Human focus on where you put your time and attention is another. But to do this requires significant constraints to the solution space. Like you really got to think through, are you going to constrain it with documents or are you going to constrain it some other way? We applied an architectural pattern coupled with schema-validated YAML, but there are other ways to do it. Then the other interesting thing, I didn't expect this, but sometimes better AI is less AI. That wasn't the path we started down, but it's kind of where we ended up. And I want to leave you with one challenge. Why does a spec need to be a set of markdown files? This was one of the things I had a realization on early on, and I'm glad I did. And Brigitta's article helped push me down that. But it was like, markdown files are great for requirements, but it's not the best for like defining architecture, design, and to try to be source of truth. So some examples of that would be, we have so many other artifacts we could be looking at, right? We could look at Gherkin, behavior-driven design, fact-based test cases are starting to look interesting. Event flow diagrams, state machines. Like nearly every one of these applies a lot more constraints on a system than English markdown files, and arguably are easier for human AI collaboration. So they're worth considering. So if anybody comes up with some novel approaches along those lines, feel free, happy to reach out. I'd love to talk about alternative ways of constraining AI and making meaningful systems. And throw my contact info and the demo information here.